Okay, let's touch briefly on the evidence. Okay, this is what we have, and what I want to emphasize through this section of the presentation is remaining objective, to use your own intellect, to use your own power of reason, and just answer the questions as you see it, not as somebody else is telling you, not even me. I mean, ask these questions for yourself. Try to remain objective, try to divorce yourself from emotion, and try to just answer the questions that I'll be raising as we go through this. The first thing that I need to say is that the strength of a theory is its ability to predict what we do not yet know. All right, let's think about that for a minute. For example, Einstein's theory. We're all familiar with the equation. E equals mc squared. Kind of mind-boggling what that even means, but we're all familiar. But that equation means some outcomes. We should be able to see some things in the universe if that is true. And one of the things that Einstein predicted, which just blows my mind that you can even come up with a prediction like this. I mean, it demonstrates to me the power of his mind to even conceive of this. But he predicted that you could bend light. I mean, you could bend this stuff. Light would bend. I mean, that blows my mind just to think about that prediction. I mean, how do you even come up with an idea like that? Bending light. But it turns out that light bends, that we now know, and he predicted this decades in advance of our knowing, that we now see the lensing effect of distant stars as light is bent by strong gravitational bodies between the distant star and us as we observe it. So we know that light can be bent now. I mean, it can be so bent that it, like for instance, if it falls into a black hole, it never escapes. So, I mean, radical prediction, but smacked it out of the park. Talk about a strong prediction, or talk about a strong theory, I should say. The ability to predict what we do not yet know. I mean, he predicted one of the most bizarre concepts. But as bizarre as bending light is, what's even more peculiar, and what even more bizarre of a prediction is that time can stretch. That one warps my mind. That one, stretching time, that time is not a constant, that it's elastic, that it can collapse, that it can contract and expand like silly putty, that it's compressed, and that it has energy available for work. That just blows my mind. What horsepower, what intellectual horsepower and torque to be able to conceive of a prediction like that, that time is part of the dimensional aspect of the universe. And that's amazing. But man, he smacked it out of the park again. He's batting 1,000. Strong theory, predicting stuff that we do not yet know, decades in advance of our ability to even know. Batting 1,000. Okay, so that's an example of a strong theory. Now, let's just take off the Darwinian eyeglasses, if you will, just for a minute. Trust me, they'll be there when you get back. But let's take a look at the strength of Darwin's theory, okay? And just answer the questions as honestly and objectively as you can. All right. If Darwin's theory is correct, we should see evidence of it in the fossil record. Darwin's theory assumes, and again, this is one of those phrases you can Google. It's called uniformitarianism. And its counterpart is catastrophism. The uniformitarianism is what we find behind door number 1. Catastrophism is what we find behind door number 2. Uniformitarianism is a creed or a doctrine, and it's basically the idea that the processes, the geological processes that we observe now have continued uninterrupted, pretty much without change, into the distant past. For billions of years, pretty much unchanged. And so, if this creed is true, what that means is that we have this slow, gradual aggregation of layers of sediment building up over eons and eons of time. And what that means is that the deeper we dig a hole into the dirt, the farther back in time we are going. That's what Darwin's theory predicts. Therefore, if that is an accurate picture of the distant past, what we should find in these deep layers of strata are simple life forms. And sure, there's going to be interruptions in that, but in general, what we should find is we should find in very deep levels of strata, we should find simple life forms. And these life forms should gradually become more and more complex. And we should see an example in Darwin's tree of life demonstrated for us in the geological table. That's a prediction that the theory makes. The theory predicts that this is what we'll find. The strength of a theory is its ability to predict what we do not yet know. Is that what we find? Okay, this is where you have to really take off your Darwinian glasses, because you'll hear guys like, Dawkins and Tyson and the rest. They'll talk about, oh, I challenge you to find one example of a contradiction to Darwin's theory in the fossil record. I can tell you right now, and you can look it up for yourself. They're called polystrates. Polystrates. I'm not going to go into it right now, but they're in every coal mine on the planet, these polystrates. Look it up. But anyhow, what we should find in general, we should find a gradual increase of complexity in the life forms that we dig out of the layers of dirt. What do we find? We find what's called the Cambrian explosion. And in the Cambrian explosion, we find all life forms jumbled together at the same time, in the same strata. We find every phylum, class, order, genus, and species that we presently see. All deep, deep, deep in these deep layers of strata. Every life form, every phylum, class, order, genus, and species that we know of. In fact, we find a much more vibrant and lush environment down in these deep stratas. How's Darwin's theory doing? Is it predicting what we do not yet know? Is what we're finding backing up his theory? I look at the Cambrian explosion, I say, strike one. Come on, Chuck. Come on, keep your eye on the ball. You can do better. Come on. All right, if Darwin's theory is accurate, a fairly accurate presentation of what took place in the distant past, then there's another prediction that we should be able to find in the fossil record, and it's transitional forms. Here's a phrase for you. If you're not familiar, look it up. Transitional forms are just in-betweeners. For example, Darwinists believe that mammals had to go back to the ocean because we've got whales and dolphins, and those are mammals. And so at some point in the distant past, some dog-like creature had to start becoming more and more, less and less a dog and more a dolphin. And so the prediction that Darwin's theory makes is that we should literally, no exaggeration here, folks, we should find mountains, literal mountains of these transitional forms. Mountains of the in-betweeners. In fact, we should find so many transitional forms that it should be difficult for us to classify species. It should be a huge swath of gray zone. We should find something between the dog and the dolphin called a dog fin, and all the gradients from dog to dog fin. And we should find this huge swath of fossil evidence for the dog fin to the dolphin, and all the gradients there. And that's just one of the family trees that we should find. The transitional forms should be so abundant. I mean, they should outweigh what we're actually finding, which is distinct delineation of species. How is his prediction doing? Just answer the question honestly with objectivity. Use your own brain. Is Darwin's theory predicting what we're finding? Is what we're finding supporting Darwin's theory? How are we doing on the whole transitional form thing? Well, I think if you're honest, you got to say strike two. Come on, Chuck, keep your eye on the ball. You got to make mention of a few of the transitional forms. I mean, even in Darwin's day, he was concerned about the paucity. The paucity, it's a fancy word for saying there aren't very many. He was concerned about I can't think of another word, the paucity. He was concerned about the paucity of transitional forms. And so what have we found in the last 150 years? Well, we had several Darwinian hoaxes that are still in the human family tree. We had paleontologists coming along saying, well, we know evolution is correct, but we just can't seem to find the damn missing link. So we'll help it out. We had one guy come up with I think it was Piltdown Man, where he took the cranium of a human and the jawbone of a chimpanzee, steeped them in tea for a couple of weeks to give it a nice aged patina, and boom, there we have it. Man's ancestor. Transitional form between ape and man. Woo! And Piltdown. Piltdown's still in our family tree. We had Peking. I may have reversed the order. Somebody can correct me if I'm wrong. But Peking Man, he's in our family tree. He was made up from the tooth of a pig. From whole cloth. The tooth of a pig. This is in our family tree. So you got the Darwin's hoaxes. Then we have a few very controversial suspects. We've got Lucy. Here's a primate with no hands or feet, but with a knee bone that apparently supported upright walking. But unfortunately, the knee bone was found hundreds of yards away from the primate with no hands or feet. And there's Lucy. Okay, strong. There we go. Excellent work. Here's a good one. We got this huge skeleton of a whale. It's found in Sahara. Things like 150 feet long or something like that. And the Darwinists are saying, "Oh, we're so excited about this find. We've uncovered the vestigial remains of the back legs on this whale." And I'm thinking to myself, dude, if you're like 150 feet long, there's like a 4-second delay from your brain to your pelvis and back. So you're going to need some help down there with the ladies. You know, those aren't vestigial remains of legs. Those are hooks, man. Those help you. You're going to need some help down there. So anyhow, this is what we're coming up with after 150 years of furiously picking away at the dirt. We got a few controversial suspects. So I'm calling that strike two. It's not supporting Darwin's theory. We're finding the opposite. Another prediction that Darwin's theory should make is that it's along the same lines as the transitional forms. But the transitional forms should be there, and we should find tremendous change over long periods of time. But what do we actually find? I mean, we got, geologists and paleontologists digging these fossils out of the dirt. They're giving these quotes, 250 million years old, and it's an alligator. It's no change from modern alligators? Nothing. You can't even tell it other than that it's much larger. In general, everything they're digging out of the dirt from the distant past is much larger. But no change from today's modern, living relative. You got insects, 300 million years old. Mosquitoes, spiders, dragonflies. You can't tell the difference between what they were 300 million years ago and today's modern version. No change, nothing. What is that? Tremendous stability. What happened? Did the mosquito just get stuck? It just hit its present life form 350 million years ago and it just didn't change. Spiders, dragonflies, reptiles. Tremendous stability over long periods of time. And we know the reason for it today. We know that there's error correcting software built into life forms that is resistant to change. That's why mutations are so dangerous. They're not helpful. They're harmful. Get into that later. So strike three. I mean, honestly, just answer the question. How's Darwin's theory doing? The predictions that he needs to support his theory, are we finding them? We're finding just the opposite. So, I hope you weigh this with a fresh set of eyes. I hope you hear this with a fresh set of ears. And just answer the questions, not on the basis of what experts tell you or what you've been indoctrinated with throughout your entire educational career. How's he doing? I think he's striking out. I don't think it's a strong theory at all. You be the judge.